fifth chapter of how we look. And I know from just speaking to members of staff, just individually, people have got so much from that already. So really excited about what he's going to bring to us today. So pass over to Harry.
Thanks very much. Thanks for having me. Thanks particularly those of you who I saw wandered into your lesson loudly with the student tour earlier. I've been really keen to come for ages. Particularly because my mini bio, I taught in Japan and then in India and North London, and then in 2012 I was part of the founding team at Free School. We had Mark Mahane come to our school in somewhere in year one to be like, this is what Ofsted are going to be looking for. Shortly before Ofsted came and pasted us, which is another story. But so I've been really keen to find out about what's going on here. It's been great to finally be here. And then somewhere along the line of this biography, I got really into formative assessment, and last year, or 2 years ago, wrote the book that you read, and that's what Belinda asked me to come and talk about today. And so the chapter, as you know, is all about hinge questions. And rather than teaching you to suck eggs, I thought it was worth finding out where you're at, so I can sort of pitch what happens thereafter. So can I give you a second to read what's going to come up and work out which numbered box you sit in, as it were. 1 to 6. So let's see if this works. We'll try it in like hinge question style. So if you're in number 1, so like pretty new to you, but you read the chapter and you were like, yeah, like the idea, you hold up one finger for me in a second. And if you're in number 5, like there's a hinge question every lesson, and you're just perfecting them and like writing your own book of them. It doesn't have to be like that. 5 fingers and so on. You will just show me your fingers to give me a sense of where you're at. Cool, okay, thank you very much. So, yeah, just stop me as you go along. Like, you've read the chapter, so some of it will not be particularly surprising. However, I did finish writing the book a year and a half ago, so there's a few more things that I've learned since. Take things one step at a time. Why worry about what we're going to worry about? What are students thinking, and how can we respond? So talking in the introduction of the book about the difference between exotic and endemic problems. So the exotic problem is like the one time in my entire career that a wasp flew into the classroom and the kids all went mad. It's like this old 1960s building with the windows didn't open properly, and I'm like, I'm not going to get this wasp out, and the lesson's just going to, it was a class who I could not control even on a good day. It's just all going to get worse. And that's, you know, like that makes a much better story than an endemic problem. But it's not really worth spending an afternoon training session about very often. Whereas pretty much every lesson, a student will get to a point and I'll just be like, I think I'm kind of done here. Like, I've worked hard this morning, I'm tired, I think I'm going to take the rest of the lesson off. And they'll just sort of sink into their chair and their hand won't stick up anymore. So, endemic problems are the ones worth focusing on. Think about one particular endemic problem. What's going to happen after you're brilliant? It's the best explanation. No one could have bettered it. Then what's going to happen? Stephen, if you're going to tell me. Go ahead, sir.
Different interpretations of it.
They're going to have like these, yeah, they're going to believe things that you definitely did not say and that were possibly the opposite of what you said. What's the other thing that's going to happen based on our science of learning stuff?
Oh, well, I was going to say some of them weren't listening.
So potentially some of them weren't listening. I guess I'm going to assume that your explanation was so brilliant, no one was unable to listen. But yes, that is another possibility. Science of learning wise though, yeah.
Oh, sorry, again. When they're like, I don't get it.
Yeah, they actually will get it, but they won't believe that they get it. Or, yeah, something's going on there. Yeah, go ahead.
Some of them will understand.
So, yeah, why do we have to be so negative? It's much easier if we start negative, because then I can sell you the positive. But yes, some of them will understand, yeah.
Some of them won't remember what you said.
Yeah, and if they do remember, it will start going, as we know from the whole forgetting curve stuff. Who's going to understand?
Oh, mixed bag.
Yeah, we don't know, do we? It's not like we can say, like, you guys definitely got it, so I'm just not going to leave you, go on with the questions, unless we're, like, even sometimes you've got kids who seem to be really on it, and then you push a little bit, and you're like, you're just really good at nodding and, like, copying the answers out, aren't you? So, this thing of misconceptions, they've got these wildly different interpretations. We'll come back to finding out who's who in a second. My favourite example in the whole world came from one of my trainees who was like, yeah, one of my kids came in the other day, he said, yeah, before the Reformation, there was only one church. And it was really tedious because you had to walk for miles to all get to this one church. So he's got this impression that a church just means a building, which is fair enough. A church is a building. And as historians, we just switch between church as an institution, church as a building, often quite thoughtlessly, fluidly, because we're used to the idea it could be both. And to pin down what I mean by misconception, if you say what's 3 times 3 and they're like, no idea, that's not misconception, that's just a lack of knowledge. Fine, tell them, teach them, whatever it is. That I would call an error, and that I would call a misconception. Because I think there's something here, they're doing something, like, are they mixing up multiplication and addition? Are they mixing up the symbols? Something like that, which is different from a pure error. So with that in mind, just on your table, just take 2 minutes and share one of these each. Please try and restrict yourself to just one. Sorry to interrupt, I know some of you guys got some questions to that. Just here, a couple of particularly egregious, alarming, or just bizarre ones.
So we were just talking about, we've just done some exam marking, and I marked a paper where the students talked about personification, which is really give inanimate object properties of a human or of something that's alive. But they had given a quotation that was describing surfers, who were obviously people, as having emotions, and then said this is personification because it's describing them as if they're alive. It's like, I think the surfers are people and are alive. So they obviously had just had a misconception about what personification actually means.
And the biggest source of misconceptions, I think, is sort of oversimplification. It's lack of nuance. So one of the simplest examples of misconception is, say, how do you multiply something by 10? We stick 0 on the end, which is a really useful rule until you multiply by 10. But when they're first introduced to it by a parent or a year 2 teacher, no one's thinking like, oh, in 5 years' time that's going to be really problematic. We had a couple, we had both print and fetch being used as commands, and the kids thinking like, print means it physically prints rather than prints on the computer scheme. Fetch meaning, what was it?
You go and get something.
You literally go and get something. It's just a very concrete interpretation of the world, which is fine. On the one hand, alarming because potentially there's a really big gap in students' knowledge. Personification, problematic if you're going to use it, but not the end of the world. Sometimes we're looking at like quite fundamental pillars where they just have no idea about something. We had people talking, well, a couple of tables about use of a negative. Do you guys want to tell us what you were talking about with maths?
Yeah, so students tend to ignore any rules you tell them or ways to teach them about negative numbers and pretty much look at the first number in the calculation, and if it's negative, they assume the answer will be negative regardless of what is happening in between. Because they just overlook whatever you try to say.
So while I contend that personification is problematic, alarming, and what's changing, that is like nothing in maths. No sum is going to make sense as long as you follow that rule. So how can we use misconceptions? Let me show you this sort of science guy who thinks they're a good thing.
Hey YouTube, you said you wanted to talk. What's up? Why do you go around making other people look stupid? What do you mean? What's water made of?
Water?
Yeah. What makes water?
Water.
Okay, what elements does it take to make water?
H2O.
So what does that mean?
It is water.
Okay, so that was one example. Really?
The carbon dioxide, everything emits carbon dioxide, trees, human beings, I guess like animals,
So
and
the trees are contributing to the...
Oh, definitely, but it's definitely. So yeah, so for trees are I guess the one of the original primary sources for emitters of CO2. So trees are just like anything else on this earth that emits carbon dioxide.
I could do this all day. Enough. You know what I think? I think you do it to make yourself look superior. Oh yeah, maybe that's it. Maybe I'm just a giant egotistical jerk who delights in humiliating other people. Well, that fact certainly hasn't gone unnoticed by your viewers. You come across a little condescending in these interviews. You basically set up every single question to make other people look like idiots. This guy is a pretentious douchebag. Now that's hurtful. I hate this YouTube channel. It makes every single person it interviews look like a complete retard. Not everyone's a physicist, so get the fuck over it. Stop, alright? My viewers don't own me. Actually, you should have read those T's and C's a little more carefully. By seeing your ads, your viewers do, in fact, own you. Oh, man. Yeah, now, come on, just between you and me, how closely do you have to pick through those interviews to make people look that dumb? I mean, some of them. If you want to see the complete interviews, then why don't you click the annotation? You can judge for yourself. Did you ever think that the reason that I start with the misconceptions is because I wrote my PhD on how to design films to teach physics? And I found that if you just say the correct stuff, trees get most of their mass from carbon dioxide. Yep, pretty much covers it. Viewers don't actually learn anything. They just feel like they're learning and become more confident in the things that they thought beforehand. So what you're saying is you make people look stupid so that you can teach others. How noble. But that's just it. I don't think these people are stupid. There's a difference between being unknowledgeable and being unintelligent. I mean, I'm unknowledgeable about lots of stuff. And science can be hard for the particular reason that it's counterintuitive. So I think we should acknowledge what everyone's thinking, what most people are thinking, and use that as our basis for teaching. But if you actually believe that, why does your face light up with glee every time you hear a misconception? Because in that moment, I realize that I can be useful. I can help people learn the truth. And that's the point of Veritasium, to help people understand the truth of the natural world and to get them to seek the truth in their own lives. As Richard Feynman said, the first principle is that you must not fool yourself, and you are the easiest person to fool.
So those are things that you could pull out of that. Just a couple to highlight though. So misconceptions aren't just a problem, they're potentially also a really good entry point to teaching. I think that's one of the things that I'm trying to sort of push onto you. Everyone's got them. They are everywhere. So, if we believe in this, what are we going to do about it? Graham Nuttall, who wrote this beautiful book, Hidden Lives of Learners, talked about the job of the teacher being to be constantly monitoring what students are understanding, because your job is to change the way they think. So you have to constantly be seeking to find out what students are thinking as they go along. But the problem is what students think is wildly opaque. I'm standing here being like, some of you guys are smiling and nodding, and I've got no idea what's going on in your heads. Some of you think about your marking, some of you think about tea. So what do we do about that? How do we know what students are thinking? One thing that we do, which Doug Lemov describes quite nicely, is we ask them, we say, everyone got it? And as Lemov points out, even if someone were able to pinpoint a gap in their knowledge and describe it in the 3-second pause that we give before we say, right, time to get on with the exercises, they probably wouldn't have the guts to stop the entire class. They'd assume it's just there, right? And so they just let you move on. We ask probing questions. But while I'm busy asking you my really well thought out, excellent, directed probing questions, a lot of other people are potentially switching off. Or I'm doing a quick Dylan William, I'm going to do a pose, pause, bounce, 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 bounce. But if I do that, I never have the chance to really properly interrogate your thinking. These guys say, what we need is something that would be the equivalent of an individual interview with students from everyone at once. And so the fashion was, and I guess it still is, we'll get into whole class checks. So is everyone happy? Thumbs up, thumbs down. I think that has a role. It's better than nothing. You might have read that if you read the chapter from the book. If doctors, professionals, who are paid to be good at this don't know, the chances that students are going to accurately self-assess and then tell you the truth are quite slim. And so we come to the hint question. You knew where I was going with this. And we come first to this example, which is that's your standard multiple choice question, I reckon. It's put together maybe for a quiz show or something. Not very thoughtfully. You only have to know which century Martin Luther King was alive in order to know the correct answer. Or you use Duolingo for languages, if you use that. Trying to learn a bit of French. I think, I don't know what that means, so it could be true, but I know that chemise is a shirt, so it's not that. And I know that that means sell. Don't have to think particularly hard in order to guess the right answer there. If we tighten it up a little bit, we can do something quite a lot more interesting. And we can start to get to this issue of nuance. How tightly do students understand what's going on? One of the problems, sort of a fundamental misconception in history is a kind of great man sense of history. Because Hitler did this, as though Hitler was personally walking around Germany telling everyone what to do. In the same way, because Martin Luther King did this, by offering students 3 different campaigns, all of which were happening at the same time, more or less, all of which used the same methods that Martin Luther King advocated, but only one of which was actually led by him, you start to get students thinking in a much more complicated way about what's going on. You start to appreciate what life is really like. And Duolingo, I like to slag them off, and then maybe a year ago they changed what they were doing and actually started putting in some slightly better questions. So here, I actually have to read this properly and check, is it garçon just with the funny little accent there, or is it this one? Or is this the correct spelling? Which word is going to be masculine or feminine? So suddenly, by tightening up on my multiple choice questions, we can find out whether students are paying attention, whether or not what their misconceptions are, and we can start getting them thinking quite a lot harder about the subject. We can use it for stuff like grammar. We can use it to do the same thing again and again. Those of you who don't teach history history may not be aware that everything that's in black and white is older than things that are in colour. So this Roman aqueduct is newer than this Industrial Revolution factory. So every time I have a set of pictures like this, the kids are going to see one trick picture that is black and white that's newer than something else until they stop believing that that's true. So we can do it with persistent misconceptions and keep coming back to them. This is one of my favourite of the lot. Let's test your math skills. So do you think it's A, one finger, B, two fingers, C, three fingers, and so on? And can you hold your fingers up in 3, 2, and 1? Cool, I heard some muttering because some people noticed that there were 2 correct answers, but you don't have to tell the students that, at which point people worry about guessing. But if you don't tell them how many are correct or incorrect, the chances of guessing from this correctly are pretty slim. What I really like about this is, again, it just pushes, like, we've been telling the kids for ages, a squared plus b squared equals c squared in a right-angled triangle. But do they actually really get, so, you know, the heights and the longest one, do they actually get where a and b have to be in order for that to be true? So for the, b and d. The other thing to highlight there is, if anyone felt a little bit like, oh my god, he's going to catch me out, why is he making me answer this maths question, I'm not a maths teacher. Some of your kids will think that when you apply this in the classroom. So it's worth thinking about how you try and like line it up, make it safe. Don't worry, no one's looking. Maybe heads go down and hands go up if you think there's going to be an issue because you're not going to get true answers. Because many kids are used to being able to tick along and not necessarily be challenged all the time. So if we change that, we want to think about how we're doing it. What else does this do for us? Rather than getting everyone to do this, science people, which of these do you prefer? Or anyone with an interest in science, no limit. Any science teachers in the room? Or those with an interest in science? You happy with A? Yeah? C. Which are you more happy with out of A and C? Why? Yeah. And so what we can see here is a kind of progression from quite a naive thing, like gravity's the thing that holds you down. Again, that's potentially your primary school explanation. Say, the table's in the way, like, it's probably a bit better than D, and then C is what a scientifically correct answer would look like. So we can start to show that, so don't have examples of whole paragraphs of text, you can't read them. But we can use this, again, in quite sophisticated ways to say, read these 3 introductory sentences to a paragraph. Read these 3 introductory sentences to an essay. Which of them is the best, not just which of them contains a misconception. And subjects like English and history are always like, we're special, it doesn't really fit our work. As a historian, I'm well equipped to say that's not true. I think it can work nicely for subjects like English as well, to catch which of these things are true. Like, Romeo's in love with Juliet, they've not met yet. If you're skipping ahead or you're just going for quite a basic understanding of the play, you're going to get caught out there. And so what we come down to is something that looks a little bit like this. Dylan William uses the term cognitive rule. Like, think of that as like anything that people might think. A misconception, an interpretation, a way of understanding the world, the belief that the church is just a building. Whatever cognitive rule is, we want to have one and only one answer that encapsulates that belief. So we've talked about this thing of probing questions, like if I'm sitting there being like, but what did you mean when you said B? I no longer have an overview of what the room thinks. I'm back to a discussion. So I want to be absolutely confident that when a student chooses A, they've fallen into misconception A and nothing else. Three stages, I think, to designing a hinge question. We quite often try and start with a question, and that makes it really hard. The easiest thing is to start with a misconception. So, why do objects sink? Obviously, they sink because they're heavy. But according to scientists, it's not because they're heavy, it's because they're dense. Classic misconception, right? So, students might think that objects sink because they're heavy. So then from that, I'm going to come up with like a sentence ending. And then I'm going to come up with a question. By doing it in this order, I start with the thing that I really want to know, which is which kids hold this misconception. If I start with a question, this is how I end up with my oh, Martin Luther King, yeah, who won him against Julius Caesar? Because I'm just scratching for what would another answer be. Misconception, distractor, like sentence ending, question. That's what I'm going to ask you to do in a second. Does anyone have any questions about anything that I've said so far? So, could be based on your exam marking and the interesting things that you've turned up in that. Could be based on stuff you're going to be doing next week. Let me just invite you to take 4 minutes, 5 minutes. 1, 2 misconceptions is fine and the right answer. Turn them into sentence stems and create a question that goes with it. Any questions about it? Stick your hand up if you want to talk. answer is a formula. You've got a different number. Okay, could I interrupt there? Has anyone got a question that they're like happy with and then they use sometime this week? Yeah, go ahead.
Oh, it's very math specific. I don't think it would interest me.
It interests me. There are mathematicians in the room. Yeah, educate all of us.
Actually, Abdullah came up with it and we just altered it slightly, but it was 3 to the power of negative a half. So they have to remember that it's the square root of 1 over the square root of 36. So rather than 1/6, we put negative 6, positive 6, positive a half, positive, negative a 6, sorry, positive a 6, negative a 6, 36 squared or negative 18, a half of it.
I hope everyone followed that. So we had an interesting conversation with this group about what a good number of answers to put is, which I didn't mention, and the answer that the research suggests is as many as there are plausible distractors, which is what you're describing. Here are the different traps they might fall into. Rule of thumb, 3, 2 wrong, 1 right. But if there's only 1 wrong answer, just give them a wrong and a right. There's no point in making up spurious things they're not going to guess, chewing up their brain capacity, reading it. It's not going to be helpful. Great, thank you. Let's have one more. So, yeah. And like, we're all going to become better people through. Yeah.
Okay, so a big issue is that they don't know how to say I went properly, and I've put 5 possibilities that are all very feasible. So you've got j'ai allé, je suis allé plus infinitive, j'ai allé plus infinitive, and just je and allé, and they've got to pick from those 5, and they're all very, very clear.
Yeah. So and I was talking with these guys because I was having my definition of the church objected to, because sorry, what's your name? Janet was saying, actually in RE we have a different definition of the church again, and we was talking about how the whole process of education is just taking existing definitions and like being like, no, that's wrong. We need to be even more fine-tuned. We're just going to get even more into detail in what we're looking at. So we've got this perfect question. Now what's going to happen? Very American example. I know you're used to seeing American videos, so that's fine. Don't worry about anything except how smooth this is and what happens afterwards. And the fact that the video doesn't, this is the video that doesn't work unless I press the play button, I remember.
Good morning, Williams.
Good morning, Supermanager.
Rock, paper, scissors, number 1. Everybody on 2, 1, 2. Looking around, make sure they're nice and high. Looking around the room, see lots of 2s, couple of 4s. How can I defend my answer, whether it be decrease or increase? There we go. Blaze, track Blaze.
I know it's a decrease because it goes from $30 to beginning to $12 from beginning.
Very good. You should have written over here somewhere initial. Give yourself a check if you wrote initial. Pencil should be up. If you didn't write initial, you need to write it now. So everyone's pencil's moving. Initial is $30, and at the end of the day, you can call it a couple of different things. You got end, now, new, things like that. I'll call it new. The new amount of scholar dollars I have in my pocket are just 12. So that is definitely a decrease. So which answer choice should I choose, Elizabeth? That is correct. Answer choice B. Give yourself a check if you had answer choice B. If you did not circle that, fix it now.
What does it do at the start? Why does it work?
Clear instructions.
Clear instructions, yeah?
Getting everyone to do it at once doesn't allow them time to recheck and address
Yeah.
why they got it wrong.
Because the killer is like, I'm sitting here, I'm not really sure, but I can see that Chanel's holding up 2, and she's usually right, so I'm just going to do that. So unless you've got some kind of signal or you're keeping heads down, it's not working.
There's also familiarity. It's clearly something they've done many times.
Yeah, so there's practice gone into this, making it right. So if I were bringing this in afresh, it'd be like, here's what we're doing and why we're doing it and why I only want to know your answer, not going to catch you out, blah, 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 blah. And then here's how we're going to do this. Now we're going to rehearse it. And it's fun. Like, breaks up the general monotony of just learning stuff, which obviously is not monotonous. But like, something like that is kind of fun, particularly for younger kids you've got there. Then what happens? What does he do? And what happens in the kids' heads? Go ahead.
Well, you're asking what is he going to do next?
No, so so he's done the thing, he's seen the fingers, what does he make happen?
He checks that someone knows actually that they've not just guessed and got it right, that they're able to give the correct answer and their reasoning behind it.
Yeah, and specifically you've got is it 2, is it 4? He doesn't say, it's 4, why is this? This is the thing I see all the time, people like using this. Beautiful question goes up, and they're like, completely right, it's answer B. Why is it answer B? And so obviously, like, everyone who didn't get answer B knows they're stupid, so they stop listening. Everyone who got answer B knows they're really clever, so they stop listening. And you're back to like a one-to-one dialogue, which isn't very useful. It doesn't say that. But at the end, he's gone over the answer. What's the new answer? It's 12. Which letter is that? It's B. He's making really, really sure. I mean, sometimes you could just do the same question again, and it might be worthwhile, because sometimes kids won't get it right second time. Hopefully not, but yeah. And so at this point, you might have a thing like, if you've seen the front page, the front title of the book, like this isn't very responsive, it's just me like setting questions. So I want to talk a tiny bit about now what you're going to do. You've discovered that kids have got these massive misconceptions. Now what? Let me show you what Derek Miller does. Have a think about what you like, but also have a think about how you'd have done a better job if you were doing what he's doing.
When you touch an object and it feels warm or cold, what is that really telling you about the object? Here I have a metal hard drive and a book. Now I'm going to ask people to compare their temperatures. Which one do you think will feel warmer, the book or the hard drive?
The temperatures.
Yeah, tell me if one is hotter or colder, or if they're the same temperature. How do they feel?
This is slightly cooler than this one.
Yeah. Oh, that's warmer. Yes. Way warmer.
Yeah, agreed.
I'd say the hard drive is a lot colder than the book. I don't know, because the book's got more knowledge.
Why do you think that is?
Metal's normally a little bit chillier if you leave it in a colder temperature.
Well, what if I said that they're both at the same temperature? What would you say?
So you're lying.
But really?
I think you're lying, yeah.
Oh, jeez. Well, maybe the way I can prove it is I have an infrared thermometer. What do you think we're going to see?
I think science might be able to answer that. And I'm not a scientist.
I
Make a prediction for me.
I still think that's cool.
Would you bet me money?
I do it because I don't have any cash. So
Let's measure the temperature of the book.
Okay.
What do you see?
19.0.
Okay. And measure the temperature of that.
19.0. Alright, well now I believe you.
I'm trying to actually figure it out, actually. I'm trying to figure out why they'll be the same temperature. No, they don't feel the same temperature, though.
So why does that feel colder if they're basically the same temperature?
good on. You get an answer?
Well, I'm going to you guys for answers.
We're creatives, not intellectuals.
Well, create an answer for me.
So just come on, you tell me.
Well, I'll try to answer that question with another little experiment. Here is an aluminium block and
Nice and cold.
a plastic block. How do their temperatures compare?
Completely different. Completely different.
Much colder.
Yeah.
Yeah?
This actually feels colder.
Let's take this to the next level. I'm going to put an ice cube on both plates. What are we going to see?
Well, I'm guessing it would stay solid on this one and melt on this one.
So it's going to melt on the plastic but stay solid on the aluminium.
Yes, but maybe I'm wrong.
That one will melt more quickly than on the aluminium block.
Yes. It's a little bit colder.
Yeah, because it's cold.
Let's
I think
actually...
they can go the same.
Alright, so we put an ice cube on each of those blocks.
Wow.
What do you see?
Well, it is melting a lot quicker on the aluminium.
I got it melting.
It's melting quicker than that one, even though this is aluminium and that's plastic.
So which one felt colder?
That one,
How does that make any sense?
I have no idea.
could aluminium be bad for the environment?
How would aluminium be bad for the environment?
Well, it's thawing out the ice a lot quicker, isn't it?
So you want the answer?
Yes, please.
It's about thermal conductivity, right? The rate at which heat is transferred from one object to another. So when you felt these blocks originally, I know this one felt a lot colder. Yeah. But you know from the other example we did that they must both be at the same temperature. True. Because they've both been outside for a while. We see that the aluminium block is melting the ice faster than the plastic block because it's conducting the heat to the ice cube faster.
Okay.
With the plastic block, it's a worse thermal conductor, so heat is being transferred less quickly to this ice block instead of staying ice.
Okay. I believe you.
Makes sense?
Yes.
You know, in our first example, the hard drive felt colder even though it was at the same temperature roughly as the book. And that's because the aluminium conducts heat away from your hand faster than the book conducts heat away from your hand.
Sure, that seems logical.
Which makes the hard drive feel colder and the book feel warmer. Yes. So when you touch something, you don't actually feel temperature. You feel the rate at which heat is conducted either towards or away from you. Think about this next time you hop out of the shower in winter. It's much nicer to stand on the bath mat than on the tile beside it. Not because the bath mat is warmer, but because it conducts heat less quickly away from you.
Who knew? What does he do there? How does he use the misconceptions? How does he set up to try and take them to what he wants them to understand? Yeah.
Well, he first of all sort of challenged the first misconception that the book was warmer, but then he set that up to make them think, to basically create another misconception that the ice would melt more quickly. Then, so he created a new misconception and then demonstrated to them why that also couldn't explain what's happening, so they could see their misconception was wrong before they understood why it was wrong. And then he explained finally.
Yeah, so it's what I was just saying about not telling them the right answer. He not only did not tell them the right answer, he dug them in deeper. But you could see from their reaction, they were like, oh, this is a problem to which I want the answer. Think back to his, oh look, trees, not very interesting. Everyone's like, go on, what's going on? And that is therefore memorable as well. What does he do then? So he's dug them in deeper. What does he do to try and undick them? How does he try and show them what he wants them to understand?
I feel like this might be wrong, because I'm not a scientist, but the second example they're trying to think about, ice cube, sets up a concrete example from which they can extrapolate the meaning. I can't imagine how you go about it with the hard drive in the book, explaining how that conductivity. So he's kind of pre-laid where he's going to go, how he's going to get to that final end point.
Create a problem. Really concrete example that you cannot deny right in front of you. And it's that clash, isn't it? It feels colder but it melts faster. So you get to understand that there's something to do with conductivity. And as a teacher, what would you have done differently from him? If you were working with those guys, yeah.
I don't know if the book and the whatever the other thing was that needed if you're then going to do the exact same thing with the other two. So you could have just gone, here's the aluminium and here's the plastic, which one feels colder? Because that was still the same, the aluminium still felt colder. So was the book bit necessary?
That's interesting. I guess my counter-argument might be he wants them to understand the general concept, and so potentially seeing two examples might make it easier to transfer. I don't know, but yeah, it's an interesting point. He could have done it more simply with fewer steps.
Yeah.
Anything else? Yeah.
Could have swapped them around and done maybe the melting first, then gone, here's a book, why does it feel warmer? Maybe as a test of who's actually got it straight away.
Yeah, go ahead.
Thinking about a misconception from there, I feel like as a student I wouldn't understand why sometimes it seems to conduct in one direction and sometimes it seems to conduct in the other direction. So spending a bit more time on that and explaining the difference between them putting their hands on it and then feeling cold and then the ice cube being put on it and it melting was a bit confusing.
Yeah, I think I'd admit what you're both saying together is something to do with like, okay, here's what the truth is, make a prediction for this new one. Let's check whether or not any of this is sunk in. But what this does, bonus material, isn't in the book, because I haven't read any of this stuff. Well, not much of it as I should have done, or as I'd like to have done. We know that quite often we tell kids things and it doesn't change their minds. One of the few things that appears to is what is called a bridging analogy. And a bridging analogy goes known to an unknown. So the known is, well, the unknown is, why does it feel cold if it's actually the same temperature? The known is I've now watched what the ice cubes are doing right in front of me, and that's going to help students get to where you want them to be. So to come back to our density example, what do kids definitely know? Like, ships float, right, kids? You've seen a ship, or you've seen a ship on TV, ships float. Therefore, it cannot be weight. Now let's talk about density. So you're taking them from what they're happy with, incontrovertibly happy with, into whatever it is that you want. And the known could come from prior knowledge, could come from last lesson, but I think the more concrete it is, the easier it's going to be for students. Kids really struggle with the idea that water can, well, they really struggle with different forms of states of matter, solid, gas. The idea that water can turn into gas. But you know that clouds don't just land on your head until it's raining, and therefore it must be possible for water to become a gas, or it must be possible for water to be a gas. So kettles turning water into a gas kind of makes sense. So what I invite you to do is now think ahead. You've done your hinge question. It's a disaster. No one understands anything. What are you going to do with students that's going to clarify without completely derailing your lesson and the rest of the day? What is the 2-minute concrete example that's going to put it together for them? So just take 2 minutes, come up with a concrete example that's going to help.
evaluation, sir, and answer your question.
The best bit's going to come at the end. So you can't evaluate until you've seen chocolates that I'm going to shower you with. Go on, one concrete example. Or is anyone really selfish enough there?
I've got a similar one to what we've watched, but it's to do with specific heat capacity, so how much energy it takes to heat up different materials. And so we've said, so why is it that you can walk along the sand on the beach and it's really hot, but then you get to the water and it's fine. And so that's what they know. They know the sand's really hot, it's really cool. This is similar to the fact that it takes more energy to heat up water than it does the sand, so it's much quicker.
Yeah, so you're taking it somewhere quite complicated from somewhere really simple in your experience. Before sort of random thoughts for you, it takes time to write a good hinge question, but it is a worthy investment because misconceptions very rarely change. And new film will come out with something wacky happening in history or space, and kids will come in, is it true that something, but apart from that, like fundamentally, things like rules of grammar, the French past tense, so like they are just fundamental misconceptions that people struggle with. It is much easier and more effective if you do it as a team because you'll have come across different misconceptions, you can help each other hone the question. Once you've got it, you've then got a tool that you can use for loads of different things. Entry ticket to the lesson, exit ticket from the lesson, revision quiz, stick it on the end of an exam. You can once you've written them, they're really adaptable. And the other thing they do is say, okay, I'm only going to ask one of these in the lesson because it takes a while. What is the key point of the lesson? They can help us hone our planning as well. I plan to do something. What are you going to do with these? And if so, on what? Tuesday? When? Or what do you want to learn more about? Have you got any questions that are not being covered? Take it either. Go ahead.
So I don't use these at the moment, partly because of the time aspect, but I do use mini whiteboards to get, like, ask a question and we get a snapshot of where the misconceptions are. So I was wondering, to what extent does multiple choice add something to that process?
I at one stage got kids to like write when you write, they'd write like a whole paragraph and I couldn't read it. It's the ability to make a decision about what to do next, like that, is what I think it makes easier for us. Any other questions? It's getting late, isn't it? Let's all go home. I know Belinda especially extended this. It's like, thanks, Belinda. So, that's the book. You've read some of it. If you want to read more, feel free. If this goes really well, email me and tell me about it. If it's a disaster, email me and tell me about it. That's the blog if you don't want to shout out the book. And that's the Twitter handle if you want occasional research papers and blogs. Otherwise, thank you very much for